This is Fort Pierce, Florida. And so I already set up the bed composition file. As you can see, there's a 3 data set here, and also 2 layer thickness, layer 1 and layer 2. So layer 3 will be copy from a layer 2 and the thickness. So the thickness is the initial thickness, right? So when you do multiple grain size simulation, so your thickness will be varying. It will be changed. It depends on erosion and deposition kind of thing. And also your bed composition will be changed. Your D16, D50, D84 will change with time too. So after you finish run the model, you can bring in bed composition file, all the input. You can see the bed composition change. Like you check any data set D16 or D50, so you see it changes with time. It's not constant. But single grain size sediment transport do not change bed composition. So your D50 will be constant all the time. So here we just focus on the sediment transport page. So I open that page, go through the setup for sediment transport model. So you go to model control, right? So you're all familiar with that. Okay, you check sediment transport page. So here I set up a model. Original model simulation is 45 days. So I changed to 10 days. So if you have interest after the webinar, you can download the file and make a run yourself, see. And then after that, check result and see how it look. Yeah, I changed to 10 days. So you can run 10 days, maybe take a few hours to run. And here, I show most of the interface in the presentation. And you see so I check the calculated sediment transport, trigger that model. And then you can see the formulation is net, is a non-equilibrium total load. And there are some other option, not for implicit solver, is for explicit. So implicit is a net total load transport. And then after the model selection, you have a transport formula. So you have four selection, right? So you can see later on we were adding seashore model to calculate transport formula. And latest testing show the seashore transport formula generate not much. It's better result for cross-shore transport and also the vertical profile change compared to other formula. And then follow that is a concentration profile. So that determines that correction factor. And there's a few options, right? Exponential, Ross, long circle, and fan right. And the default value is exponential. And most time we don't change. And if for some transport formula you think you need to see the difference, maybe you can try the other profile. And then we have a constant sediment density and also porosity. We pick 0.4 and density is 2650 kilo per cubic meter. So scaling factor. For bed load and suspended load scaling factor, we choose 0.2. The default value is 1. So you can just from 0.1 to 1, maybe more than 1, 2. Depends on your case. Morphological acceleration factor is 1, 2. and bed load diffusion coefficient is 0.1, and hiding exposure coefficient is 1. Yeah. For adaptation length, I pick a constant length. Then if you click this tab, you see there's other option, right? Like I described in the slide. And there's constant time, and there's a bed suspended adaptation length selection based on those adaptation lengths. And I pick a constant length, and so equal to 10 meter. If you, like I said, the adaptation length is basically a function of a grid size. So if you have a big grid size, so the constant length may not be sensitive to different value. And in that case, I mean, it really doesn't matter much for your result. And this part, sediment size class, the interface is a little bit different. I'm using Mitch Brown's machine. He has a 13.0.9 on his machine. So I have the slide, the picture on the slide is a 13.0.8 version of SMS. So which is the same as the one you have on your AC machine. And so we are in the processing modifying interface. So right now, it looks a little bit different. Yeah, but you can see the grain size peak is shown here, right? There are 6 grain size from 0.01 to 6. And then there's an extra button here for 13.0.9. It's a show advanced size class option. So if you check this one, you come to that page I show you for 13.0.8. You can insert a line here, and then you can specify your transport grain size here. And then you see fall velocity and shape factor and critical shear stress. Those are all default value. And then if you're adding more grain size, you can adding more line here, right? Insert below. You see my first one is 0.01, for example, 0.021, and then the other value. So you can add in your transport grain size here. So this part is a little bit different. But for 13.0.8, if you're using that right now, so you can check my slide. The interface show there is corresponding to 13.0.8. Here is a bed composition. And you see my maximum number of layer is 5. Minimum layer thickness is 0.05. Maximum is 0.5. And the maximum layer thickness, I choose constant. You can see they're automatic, right? Automatic is calculated by the model. Yeah. So mixed layer, the first layer thickness is 0.05, is 5 centimeter. And then for bed thickness, I specify 2 layer thickness, 1 and 2. So each layer, the bed composition based on the data set generated, D16, D50, D84. So if you set up the model initially, so you click D16, so you can select the data set you generated, right? D16. Or if you don't have that data set, you can create the data set. You can create the data set, D16. And after that come to here, and then assign a value for the data set. So I already have it generated here. So I can just select the data set for D16. And same way for D50, D50, D84. So D50 here, D84 here. So this is the way how you specify bed thickness and a link to the model. So after that is just calculate avalanche, and also if you check that, you see the angle of repose. So default value is 32, as I showed earlier. You can change this value, do some sensitivity test. And also hard bottom here checked. And yeah. So after setting this, you can save, export, and launch CMS simulation. And in my case, I didn't change anything here, and I can just launch the simulation. It takes a few hours. So after webinar, if you like, you can have some run, have fun to to do model. Tomorrow, I'm going to talk about some new feature, not sea level rise, put in the model simulation. That's a new feature we put in CMS. And the other thing is salinity temperature calculation in CMS. So that's also part of a talk. And these three topics will be presented tomorrow at the same time.